Hey, 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 it's Dr. J. Today we're going to learn about the addition and subtraction formulas, trigonometric, of course. Interesting, we start with cosine. So suppose I wanted to add two angles. How would I find the cosine of the sum of two angles, S and T? Well, I could just give you the formula and say, there it is. But I'm going to demonstrate the proof of the formula, or the origins of the formula. You can consider it a proof. And then when we're done with my demonstrations, one of my most favorite presentations in all of trigonometry. So it kind of reviews everything that you've learned about geometry and trigonometry and the like. So here we go. So all of this exists on the unit circle. It's not the best circle, but it'll do for practical purposes. And S and T are angles starting right here at this initial point called P0. Yeah, P0 is the point 1, 0. This is the point on the unit circle. Okay, and remember, it's been a while since you did trigonometry. Angles, positive angles go counterclockwise. Negative angles go clockwise. So let's start with T. So T would be the angle from P0 to this point here. I guess I'll call this Q. Q1. So that'll be cosine T, comma sine T. Right. Remember, cosine is the x coordinate and sine is the y coordinate. I'm not going to use the letters x and y. That is x and this is y. All right. If I bring in the letters x and y, it'll become alphabet soup and we'll be lost in no time. So that's our angle T. Then going from Q1 to another point here, we're going to call this P1. All right. P1 is, we'll call this S. So altogether, this angle here from the x-axis all the way to P1, this angle here is S plus T. That's this angle all the way from here, the x-axis, all the way to the point P1. We're going to call that S plus T. Right? It's the sum of S and T. So that means P1 will be cosine S plus T, comma sine S plus T. Again, this is the x coordinate and this is the y coordinate. Sometimes we'll use other letters than S and T. We might use A and B, or alpha, beta, or theta and phi, or whatever variables you like. In my example, I'm doing S and T. Okay. Now here's where it gets weird. All right, so I've got P0 and P1. Okay. And then I've got Q1, but notice there's no Q0. Yeah, so where's the Q0 going to come in? Well, we're going to go negative S. So whatever the arc length is on the S sector here, each one of these look like pizza slices. They're called sectors. So we're going to go negative S in the clockwise direction. That's going to be our Q0. So that'll be cosine of negative S and sine of negative S. That's our Q0. Okay. And now we're going to introduce some terminology. You know what I notice I'm looking at the screen. My picture doesn't look that great. So I'm going to just go a little bit more like this. There's my Q0. I want it to look like this angle here, S, negative S, should essentially be the same size slice as this positive S. They don't have to look identical, but the better it looks, the easier it is to understand what I'm about to say. Okay. So here's a word that we don't use very much in trigonometry, but it is an essential word. It's called a chord. A chord is a line that connects 2 points, does not passing through the center. Not necessarily through the origin. I mean, it could pass through the origin, but it's not necessary to pass through the origin. So you just take any 2 points on the circle, you draw a line connecting them, and that line is called a chord. So I'm going to form a chord P0, P1, and I'm going to form a chord Q0 and Q1. Okay. So notice, since the arc length of P1, P0, P1, yeah, use a symbol like that. That's our arc length here. I could draw it like a sector like this. Is equal to the arc length Q0, Q1 So these arc lengths are the same. The distance from P0 to P1 is the same as the arc distance from Q0 to Q1. All right. So this is called a sector. And this is the other sector. And you can see them over here. Yeah, Yeah, so this sector, I know it's not drawn to scale, but this sector, P0, P1, is the same as over here. Yeah, from P0 to P1. So that's this sector. And then this sector here, from Q0 to Q1, that would be this sector here. I'm just sort of cutting it out like a slice of pizza and putting it over here. So since these have the same arc length, that means their chords are equal. Okay. So these chords, these dotted lines are called chords. All right, so this dotted line is what I call a chord. Dotted lines are called chords. All right. I'm already out of space, so now we're going to work with the chords. Okay, we're going to work with the chords. One thing I want to do is I want to write down all of my P's and Q's so that I can erase this. I want to point something out before I erase this. Cosine is an even function. So this is going to be cosine of s. Remember we covered that in the last lecture. Cosine of negative s is the same as cosine of s. That's an even function. And sine of s is sine of negative s is negative sine of s. So we're using the fact that cosine is even and sine is odd, and we can simplify these. I want to do that now because I'm going to write down all of my P's and Q's. Okay. So let's, you ever heard this saying? Mind your P's and Q's. So we have P0 is 1, 0. P1 is cosine s plus t sine s plus t. Just copying this down because I'm about to erase it. Q0 is cosine s, negative sine s, and Q1 cosine t sine t. I might as well leave my sector diagrams over here. All right, so this is just an abstract sort of cutaway of the P sector and the Q sector. So this is the sector formed by the P's, and this is my sector formed by the Q's. All right, they have the same arc length. The arc length from P1 to P0 is the same as the arc length from Q1 to Q0. All right. Now, that's just basic geometry. If you have two points that are equidistant, then that means their chords are equal. All right. So we're not going to measure the arc length. We're going to measure the length of the chords. So find the distance or the length. Sorry, not find. Set. We don't actually care what it is. Set the lengths of each chord equal to each other. Use the distance formula. Let me write it out carefully. So we have the distance from P0 to P1 is equal to the distance from Q0 to Q1. So D stands for distance. Quick refresher of the distance formula. Remember the distance formula? Square root of something squared plus something squared. Remember that? And that should be equal to the square root of something squared plus something squared. So we need to fill in the blanks. All right, I think it was the way you probably learned in algebra was x2 minus x1 and y2 minus y1. So you got y2, x2, y1, x1. I'm not really going to use the letters x and y. I just did that in red. That just is so that you remember what formula I'm using. All right. So over here we got x2. So that's going to be cosine s plus t. All right, x2 minus x1. So minus 1. And all of that is being squared. Now we'll do our y's. y2. That's sine s plus t minus y1. Well, y1 is just 0. So I'm subtracting nothing here. In a minute, I'll get rid of that because it's nothing. All right, now these variables are hard to see. If you're having a hard time seeing this, I don't know if there's a zoom feature, but a zoom in meaning. I'll write this larger as soon as I erase all of this stuff. All right, so those are my P's. All right, so now for my Q's, over on this side, I've got my Y2 and my X2. I got my Y1 and my X1. So all of these guys now, the Q's are going to go on this side. So let's see, x2, that's going to be cos t minus cos s. I should probably use parentheses around the arguments so I can tell what I'm talking about. All right. And then for the y's, I'm going to do sine t, minus negative sine s. And then all of that is squared. So that's sine t minus a negative. So that's why there are two negatives here, because it's minus a negative. Okay, I know that these distances are equal to each other. So I've got the square root of cosine s plus t minus 1 quantity squared plus, I'm going to omit the 0 now. I don't need that. Sine s plus t squared. So that's my left-hand side up here simplified, written a little bit larger. And I know that that's equal to the right-hand side here. So that's going to be the square root. I'm getting real tight on space up here. Square root of cos t minus cos s squared. Oh, this is going to be tough. This is sine t plus sine s. And all of that squared. I know, I need a wider board. I'll try to make it look better in the next line. Okay, so I've got the square root. Now I'm going to simplify this. So that's going to be cosine squared s plus t minus 2 cosine s plus t plus 1. All right, I'm going to leave it to you to review how to square a binomial. This is the squaring of a binomial. In basic algebra, we call that foiling. And then this one's not really a binomial. That's just one trig function. I mean, it looks like a binomial because of the s plus t, but it's just going to be sine squared s plus t. The right-hand side is still pretty messy. So I'm just going to say ditto. The right-hand side is just kind of messy. I know I'm running out of room. But if I simplify the left-hand side, it's going to give me a lot more room. So now I have cosine squared plus sine squared. That's an identity. That's the Pythagorean identity. Yeah. So this is going to join together and just become 1. So this sine squared and this cosine squared join together. They're adding together to become 1. So we're adding these two guys up, and we're getting 1. You do have to make sure it's addition if you're going to use that identity. All right, now I just made myself a bunch of room, so now I can bring all this stuff down. So that's going to be cosine t minus cosine s squared plus sine t plus sine s squared. And now the right-hand side is finally easier to read. We have square roots on both sides. I'm not sure why I waited so long. I might as well get rid of them now. We can square both sides. Now, again, I told you when you're proving an identity, if you cannot do that. I'm not really proving an identity right now. I'm solving. I'm trying to solve for this. My goal is right here. Don't forget your goal. Your goal is to solve for cosine s plus t. So I can use any technique I want. I can move stuff all around the board and things like that. Okay. I'm just trying to get rid of these square roots. So these guys are now gone. I might as well add up the ones. So now I have 2 minus 2 cosine s plus t. The square roots are gone. So now let's multiply this out. That's going to be cosine squared t minus 2 cos t cos s plus sine squared t plus 2 sine t sine s. Oh no, and then I'm running out of room. Plus sine squared s. I'm regretting using the letters S and T now. I wish I would have used A and B or alpha and beta or something like that. But whatever, I'm already neck deep. I'm not swimming back now. Okay. So let's see, what do we have here? Oh, look, we got another Pythagorean identity. Sine squared cosine squared. It is plus. Make sure it's plus. So we have another Pythagorean identity. I tell you, that one really comes in handy. Okay, so that's going to be another 1. Oh, we're missing a term. Ah, we're missing a term. We have another cosine squared s. Whew! I'm glad I caught that. Almost lost one of my terms there. I'm getting real low on space here, so I'm not going back and starting over. This is it. All right. Ah, we got another Pythagorean identity. Yeah, we got 2 different Pythagorean identities. So these 2 become 1, and these ones also become 1. Yeah, so we got 2 1s. And then we have minus 2 cosine t cosine s plus 2 sine t sine s. All right, hopefully you're not too lost. You could probably guess I'm going to combine those together to make that 2. And the left-hand side is just going to come down. Keep your mind on your goal. There's your goal. Your goal is to get the cosine all by itself. All right, so coming back here, we got 2 minus 2 cosine s plus t is equal to 2 minus 2 cosine t cosine s plus 2 sine t sine s. Our goal is to solve for cosine. So let's just do a couple little easy things. Let's subtract 2 from both sides. Now we're in basic algebra land. Just treat this like your x. You're treating the cosine s plus t like your variable. That's what you're trying to get isolated. Oh, we're so close. The last thing, divide everybody by -2. So our goal is to get the cosine by itself. And we have achieved our goal. Remember, my original question was, what is cosine s plus t? I'm trying to figure out, how do you add 2 angles when you're taking the cosine? How do you find the cosine of the addition of 2 angles? And this is it. This is how you do it. Technically, so you have a positive and a negative. So technically, this is a -1. Yeah. I don't typically write the -1. Just write negative. And I also like to put it back into alphabetical order just because it's easier to memorize that way. You could memorize it out of order. It doesn't really matter. But I find, and I know I'm not the only one, it's one of the reasons why we put the alphabet in order. Could you imagine being a little kid? You know, you're 5 or 6 years old and you're learning your ABCs and they're completely out of order. It would be very difficult to memorize them. Although you could be really philosophical about it and say, well, if you started when you were 5 years old and you memorized A, F, G, M, O, L, that would become the new order. So, I mean, there's nothing, special about the order that we have it in. That's just the order we learned it in. So anyway, since you learned it in alphabetical order as a child, I'm going to assume that you prefer alphabetical order. So this is your formula. This is the addition formula for cosine. So cosine S plus T is equal to cosine S, cosine T minus sine S, sine T. You can also do it for other variables, alpha, beta. I like this because I can get rid of the parentheses now. When you use different letters, it's easier to write. Notice if you don't use parentheses on a letter S, it looks like cos with two S's. So when you change variables, you can use less parentheses, something like that. It doesn't matter. Variables may vary. So there are lots of different presentations of this. Oh, you better get it right, though. Variables may vary, but you still have to keep it true. So alpha, beta, alpha, beta, alpha, beta. It's everybody's in alphabetical order. Hey, alpha, beta, alphabetical. That's where we get the word alphabet from. Alphabet. Yeah, alpha, beta. Okie dokie. So you got your formula. There it is. Cosine of the sum of two angles. Want to see how this works? Find the exact value of cosine 75 degrees. $75 degrees. I don't know what 75 degrees is, right? It's not one of the ones you memorize. But you did memorize 45 and 30. And you should know these angles. These are special angles that you should know. I don't know if you do. I hope that you do. If you don't, you're going to know them in 5 minutes now. So this is my alpha, this is my beta, or my S and my T, or whatever you want to call them. So we can use this formula. That's going to be cosine 45, cosine 30, minus sine 45, sine 30. You should know your special angles. 45 degrees. Or some people memorize it this way. It doesn't really look like 45 degrees, does it? Let's try to make it look more like 45 degrees. That's better. Yeah. Lots of different ways to do 45 degrees. You could even do it this way. slightly bigger. That's terrible. I'm making it worse. Slightly bigger triangle here. This would be 2, root 2, root 2. So all of these are different ways of memorizing the special angle for 45 degrees. Either way, you're going to get cosine of 45 is root 2 over 2, or you could say 1 over root 2. It means the same thing. All right, these are equivalent. I like this one. It's just easier to remember. But you can write it either way. This one is also true, 1 over root 2. So that's your special angle. This one up here is the unit circle definition of the special angle. Remember, with a unit circle, the hypotenuse is always 1. We'll talk more about that later. So that's your special angle for cosine. Notice for 45 degrees, sine is also root 2 over 2. A sine would be this one. Yeah, root 2 divided by 2. Or you could say 1 over root 2. That's also sine. For this example, I'm going to use this version. I like to have the square root up in the numerator. Okay, those are your 45s. What about your 30s? I'll remember 30 degrees. I know, I wish I had more space. 30 degrees is something like this. Again, it's a unit circle, so the radius is 1. This side is root 3 over 2, and this side is 1/2. Okay, or if you like, you can memorize this triangle. 1, 2, root 3. Either way, it's the same thing. The special triangle is just a magnified, enlarged version of the unit circle triangle. Doesn't really matter. You're still going to get the same idea. So you're going to get, either way, you're going to get cosine is radical 3 over 2. That would be the cosine. And the sine is 1/2. Yeah, 1 divided by 2, or you could just think of it as 1/2. Okay, we're ready to finish the problem. If you already had your 45s and your 30 memorized, well then you could have fast forwarded all of that and just jumped right to here. So cosine of 45, that's root 2 over 2. Cosine of 30, that's root 3 over 2. Sine of 45, sine of 45 is also root 2 over 2. And then sine of 30 is 1/2. So your final answer is radical 6 minus radical 2 all over 4. And that's your answer. Don't try to simplify it anymore. This is the exact answer, the exact value, also known as the answer. All right, radical 2 times radical 3 is radical 6. Radical 2 times 1 is just radical 2. And then the denominators are 2 times 2. So that's 4. I only write the denominator one time. I don't need to tell you that, but might as well. Not going to hurt. Okay, so that's your sum formula for cosine. What about difference? Again, you could use S and T or A and B, or I like alpha and beta. Once I learned a few Greek letters, I started to switch over in my mathematics and start to use alphas and betas and thetas. It shows a higher level of vocabulary, math vocabulary. It's fun. It's fun to write new types of letters. Okay. Well, what is this, the difference? Well, we already know the sum, so all we're going to do is rewrite this. Just rewrite as a sum and use the sum formula. The formula we just had. Gives you a chance to reproduce it. Remember, it's cosine alpha. I guess I'll use parentheses this time. Cosine negative beta minus sine alpha sine negative beta. Cosine is an even function. Can't tell you how many times we use that fact that cosine is even. And sine is odd. So that's going to be negative sine beta. Now remember, you're multiplying these guys. You're not adding them, you're multiplying them. So this is a negative times a negative. So this is going to become negative, negative, positive, sine alpha, sine beta. I like to omit the parentheses. It's just easier to remember. And there's your special formula. So this is the subtraction formula for cosine. Let's see an example. Example 2. Find the exact value of cosine of 15 degrees. Okay. So I don't know what cosine of 15 degrees. It's not one of the ones you typically memorize. But you do know 45 and 30. Yeah. Or you could do 60 minus 45. Either way, both of these will come out the correct answer. It doesn't really matter which one you use, as long as it's true. So 45 minus 30 is 15, yeah? And 60 minus 45 is also 15. So this one will have 2 correct answers. For my example, I'm not going to do it twice. I'm going to do it this way, 45 minus 30. If you want to try it the other way, you should still get the same answer. So that'll be cosine 45, cosine 30, plus, right? So the difference formula changes to plus sine 45, sine 30. I'm going to spare you all the details. You know what cosine and sine are now. We just did it. So cosine of 45 is root 2 over 2. Cosine of 30 was root 3 over 2. Sine of 45 was root 2 over 2. Sine of 30 is 1/2. And you're probably not too surprised. This comes out to be the same as the last one with a different sign. So there you go. Root 6, oh, with a different sign. The sign changes to plus. Yeah. It's this almost the same answer as 75 degrees, but it's 15 degrees. There is some symmetry here if you think about it. 15 degrees is 15 degrees away from 0, you know. Yeah. And then you might notice that 75 degrees is also 15 degrees away from 90. So there is some physical reason on the circle why these answers are so similar. Okay. All right, so you got your 2 formulas for cosine. You're going to need to know them for the test. And more important, you're going to need to have them memorized, hopefully, by the time you take calculus. Because in calculus, you're not going to get your professor drawing all the unit circle and reviewing all the trigonometric identities. They're going to be doing a problem on the board, and then in one step, they're going to employ this formula that you just need to know it. So the honeymoon is coming to an end. So drink up before it's over. Okay. Last call. Well, we did cosine. You actually don't have a formula for secant. There is a formula for secant. It's just not worth memorizing. Yeah. So the formula for secant is the reciprocal of cosine. So what we're going to do is we're going to solve for cosine and then flip our answer. Or our result. The reciprocal is also known as the flip of your answer. Now, you could do this. You could write 1 over cosine, 1 over cosine, 1 over cosine, 1 over cosine, and just carry along that 1 with you the whole time. That gets very annoying and takes up a lot of my limited space here on my whiteboard. So I'm going to ignore the 1. I'm going to solve the cosine of 195 degrees. I'm going to evaluate it, and then I'm going to flip my answer. What is 195 degrees? 195 degrees. Think of 2 angles that add up. So I want cosine of 195. All right, I'm waiting on the secant until I'm done. 2 angles that add up to 195. How about 150 plus 45? You can use any 2 angles you want, but be careful. Choose 2 angles that you already know. All right? So you already know 45. And you might think, do I already know 150? Well, you kind of do. 150 degrees is over here. So what is 150 degrees? 150 degrees is the same as 30 degrees away from the x-axis. So we can just use the reference of 30 degrees. The cosine is negative root 3 over 2. And the sine is 1/2. So the sine of 150 is 1/2. The cosine of 150 is radical 3 over 2. All right. Be careful if you go past 90 degrees, the cosine becomes negative. If you go past 180 degrees, they both become negative, sine and cosine. And if you get over here past 270 degrees, only the sine is negative and the cosine would be positive. You all know your quadrants, right? Plus, plus, minus, plus, minus, minus, and then plus, minus. So I'm going to do cosine of 150, cosine of 45. I'm using the sum formula, so that becomes subtraction. Sine of 150, sine of 45. So cosine of 150, negative radical 3 over 2. Cosine of 45, radical 2 over 2. Same as it was in the last problem. Sine of 150, that's 1/2. And then sine of 45, radical 3 over 2. You're going to notice this pattern happens quite often. This is radical 6 negative over 4 and radical 3 over 2. Oh, not radical 3. Almost screwed that up. Sine of 45 is radical 2 over 2. Look back at the previous example. So this is the correct answer. Both denominators are over 4. So we typically just write it like this, all over 4. They are both negative. So that's the cosine of 195 degrees. All right, so if you know the formula for cosine, or the two formulas for cosine, you can also do the secant. Oh, shoot! Be careful. You need to flip your result. This is not the answer yet. I got to stop looking at the clock. There's a little clock down here in the corner. It's going, Dr. Jordan, hurry up. This is the cosine. I almost blew it. I got to go back here and find the secant. Yeah. So the secant is going to be the reciprocal of this. So that's going to be 4 over negative radical 6 minus radical 2. Just flip it. You do not need to simplify. Okay. You could try to simplify this. It takes a little while. All right. It's not that bad, but I'm happy with that answer. Just as long as you don't forget to flip the cosine. I almost forgot. Yeah, I'm so happy to be done. I was ready to check out of here. Okay. And I'm coming up on an hour-long lecture already here. Before I finish this lecture, I need to at least give you the formulas for sine. Yeah, formulas for sine. All right, before I do another example, let's do the sine formulas. Sine of alpha plus beta. Again, if you already know it, you can just write it down and move on to the homework examples and such. You might already know it. You might have seen it in your Math 5 class. My experience is you might have seen it, but you might not have any idea where the formula came from. I know that's the way I was when I was your age. I just memorized the formula and I said, oh, I'll figure out what it means later. Okay, well, later is now. Let's figure out what that means. So sine alpha plus beta. We're going to use a cofunction identity. Yeah, remember, sine of alpha plus beta is equal to cosine of 90 degrees minus alpha plus beta. Yeah, that's the cofunction identity. This means the same as pi over 2. If we were doing pi over 2 in radians, yeah. I'm doing my examples right now in degrees. I will switch over to radians at some point, but right now I'm doing degrees. Okay. So what do we have? We have cosine. Let's get rid of some of these parentheses. And for simplicity, I'm just going to write 90. Because I'm going to be writing it a lot, and I don't have to write 90 degrees, 90 degrees, 90 degrees. So just bear with me there. Okay. It's understood that it's degrees. Degrees are implied. We do that a lot in mathematics. Once it's clear what we're talking about, we can just say 90, right? I don't have to say degrees every 5 seconds. And then we're going to write it this way, 90 minus alpha, and then minus beta. So this is the associative property now. I'm changing my association. Instead of associating alpha with beta, I'm associating alpha with the 90. The reason why is I want to use the formula for cosine. I already have a formula for cosine, so I can just use that over and over again. So what's the formula for cosine? It'd be cosine 90 minus alpha, cosine beta. This is minus, so that changes to plus. Sine 90 minus alpha, and sine of beta. Okay. So that's, I really am wasting a lot of space over here. I should have shifted all this over. All right, what is cosine of 90 minus alpha? It's a cofunction, so that's sine. I don't even need the parentheses anymore. Let's save some space. That's a cofunction identity. What's sine of 90 minus alpha? I think I can hear you through the internet. That's cosine. Yeah. That's why it's called cosine. It means the cofunction, the complementary function, 90 degrees. And then you have sine beta. Again, I don't need the parentheses anymore. And there you go. So sine alpha plus beta is equal to sine alpha, cosine beta, cosine alpha, sine beta. So find the exact value of sine of 105 degrees. Sine of 105 degrees. All right. right, so I don't know what 105 degrees is, but I know that I can find two smaller angles that add to 105 degrees. So that's going to be sine of 60 degrees plus 45 degrees. Any two angles that you know, that you already know the trig functions for, those are typically 30s, 60s, 90s, 45s, things like that. And they have to add to be 105. So does that add to be 105? Good. Yep. So alpha plus beta. Here's our alpha beta. Okay. So use this formula here. We have sine 60, cosine 45. Again, the degrees are understood. Plus cosine 60, sine 45. If you want to be safe, you can add the degree symbols. If you just know that that means degrees, then you don't have to put the symbols. All right, sine of 60. Remember, 60 degrees is like this. Yeah, special triangle. So sine of 60, radical 3 over 2. You don't have to worry about negatives and positives unless these angles are more than 90. Yeah. The angles are more than 90, then you need to worry about that. Cosine 45, radical 2 over 2. Remember your 45, 45. These are the only two triangles you need to memorize because the 60 also serves as the 30 if you just turn it, and the 30 would be up here. Okay, we're not using 30 in this one, though. So. All right, cosine of 60. Cosine of 60 is 1/2. My hope is that you just have these memorized. You don't even have to draw the triangles. The triangles are only if you forget your trigonometry, you have a mental reference of what it is, or maybe a physical reference. Sine of 45. Sine of 45 is radical 2 over 2. So there it is again, radical 6 over 4, radical 2 over 4. Don't try to add the 6 and the 2. They're non-like radicals. They cannot be added together. Radicals are very picky. You can only add radicals if they are exactly the same radicand. So the inside would have to be exactly the same to add them. Or you could put them into a calculator and add them, but I don't want a calculator answer. In fact, if you give me a decimal, I know you didn't do it correctly, because if you get a decimal, that's not what I'm looking for. So are you guys on board? You're probably getting exhausted by now. I've only got one more for today. We're going to do sine of the difference. You can probably guess how I'm going to do it. I'm going to rewrite it and then use the formula that we just had. So we're going to rewrite this as sine alpha plus negative beta. And then we're going to use the formula that we just had. I learned my lesson last time. I should have moved over here sooner. Yeah, so that's sine alpha cosine negative beta plus cosine alpha sine negative beta. If I really want to be safe, I'll put parentheses around everybody. Here comes those even and odds again. Cosine is even. Sine is odd. Remember, an even function basically swallows up the negative and you don't even see it. Yeah, it's like cosine of a negative is just the same as cosine of the positive angle. This one changes to negative sine of beta. And remember, you're multiplying a positive and a negative. Well, that's a nice pen. That's a nice color. Okay. So that's going to be sine alpha cosine beta minus cosine alpha sine beta. And there it is. So this is the formula for the difference, for the subtraction formula for sine. Okay, I'm going to log out in a second. Let me really quickly erase this and write down all the formulas. Addition and subtraction summary. So far, this is the way I learned them. Hey, let's use that new blue pen that I've got. Brand new blue pen. This is how I memorize them, by just writing them down repeatedly. So cosine alpha plus beta, that's cosine alpha, cosine beta, minus sine alpha, sine beta. You don't want to have to stop in the middle of a problem and think about what the formula is. You want to be able to just write that down. I only memorize this one, and then I get all the rest of them for free. So alpha minus beta, same formula. Just change the sign to plus. All right. Sine alpha plus beta, sine alpha, cosine beta, plus cosine alpha, sine beta. And finally, sine alpha minus beta, sine alpha, cosine beta minus cosine alpha sine beta. Tomorrow, we do tangent. Okay. You probably know what I'm going to say. I'll see you tomorrow. But tomorrow, we will take sines and cosines and mix them together, and that's how we're going to get the tangent. For today, Dr. Jordan signing out. Peace.